Okay, hello everyone. So now let's try to understand the numerical on your B tree. We perform the insertion and deletion operation. Make sure if you have not watched the previous video where we have understood each and every rule that we need to follow while performing the deletion operation, the link is given in the description. Make sure you go and watch the video. So now let's try to understand this question. In this one, we are given a B tree, right? We need to perform these 4 operations over here. We'll follow those rules only. Make sure a file I have already attached in the description. You can find the PDF file where all the rules are written, and we solve all the, we try to understand all the questions, all the points by using the question. Okay, now let's try to understand this example, right? So we are given a B tree. The first says we need to insert 30 over here, right? Okay, now let's try to find out how we insert the 30. So 30 is less than or 41. Okay, we'll go over here. Now 30 is greater than 29. Okay, we on this side, and now 30 will be here. The given in the given question, the order is your 3, right? Okay, so we'll move from 4177 to this side. We have 29, right? This side 28, and 30 will come in this one. So again 30 will come first, then 33 and 39. So we have these keys in this node. Now we see overflow condition, right? So this node is overflow. Overflow means we have more number of keys that we have actually stored over here, right? So in this one, what we'll do, we will split the node, right? The internal, the middle key will move to the up, that is in parent, and then we'll split the node. So after this one, 33 will go with 29. We are left with 4177. In this side, we have 29 and 33, right? Then we have 28. This side, we have 30, and this side, we have 39. On the other hand, we have these as it is. So you can just rewrite these values, right? So this is what we have received after performing the insertion operation of 30 now, right? Now let's try to understand for this tree. Let me just rewrite the tree over here and we'll perform the deletion operation. Okay. So we have 4177, 29, 33. Yeah. Okay. We'll perform deletion operation that is on 77. Again, we need to follow the same rule, right? In the previous video, we have understood 77. Again, this 77 is not the leaf node, right? So this is in the root node. So basically what we have to do, we have to find out in order predecessor and in order successor, right? So now let's see. That is what in order predecessor is what on the left subtree, need to find out the maximum key, or in order successor on the right subtree we find the minimum key, right? Now let's say in this one, this is what your predecessor, the maximum key is 61, but in this node we have only single, so single key. So the order is your 3. So how many, what should be the minimum number of keys? That is 3 by 2, your seal minus 1, that is what your 1. So at least you should have one key in a node, right? So now let's say, see, there is no option, right? So basically what we'll do, even you see in the successor as well, you have 84, that is only one. Now let's say I have deleted this 77 and I have kept the 61 in this place. So what will be the structure look like? That is 41, 61, okay? 41, 61, and the rest of the keys, let's say 29, 33, 39, 30, and 28 as it is. Now, okay, this side, let me just again write as it is. Okay, see now, for this middle one, when we shifted 61, or say we have deleted 61 from here, from the leaf, and we are shifted to the root, right? So we are left over with empty node. So when we have empty node, So now what we'll do, we have the empty node, so we are now going to fill this node, right? So we need to put this value inside this node, right? Because we have minimum requirement of one key in this one. So now this node will either go to the left sibling or go to the right sibling to ask for a key, to borrow for a key. But again, for the left sibling, there is no right sibling. For the left sibling, we have only 45. Left sibling will not be able to give any key. Now in that case, it will ask for the parent for some help. So now parent will now shift, move downwards and will merge both of them, right? So basically after that, when the parent will go down, the place of parent will empty now, right? And in the below, we are left with 45 and 48. That is what merged. Understand? Right? So now this place is vacant. Again, now rule is violated, right? So similar example we have already seen the previous video. Now the rule is violated of B tree. At least there should be one key. Now again, it will ask for the key, right? From where? To the left sibling or to the right sibling. Right sibling will not be able to give the key, but the left sibling can give the key, right? That is what 39 and 33. So we know for the left sibling, we're going to have the maximum key. That is what 33. But how it will, the key will be given through parent node, right? So means what? 33 will go over here and 41 will come over here, right? So what will be our next step? 33 will come over here. So we have 33, 61 as it is. Let me write these values as it is, 84. Now see, when 33 will go over there, this part, that is what? 41 will shift here. So 41 will come this way, right? Now again, two branches will be there. Okay, we're gonna fill. Now see, and this side, which element is left? 29. 33 have shifted. So 29. The left of 29, 28 as it is. The right of 29 is 30 as it is. But this now 39. See this 39, this branch. This is on the right of 39. Sorry, 33. The right of 33 over here, but it is now shifted over here. So it will be at the left of 41. Right of 33 and left of 41 is 39. So right of 33, left of 41 is 39. Right? And for this one, 41, we already have this value over here. That will go 45 and 48 here. This is what the rearranging is, right? How we rearrange the structure that your B tree. So after performing the deletion of 77, this is what actually we're gonna be having the B tree looks like, right? So I hope it's clear. Now let's move forward. The next says that we need to perform the delete operation of 84. Okay, so come up to this tree again. So where is 84? Again, we need to search, right? So as I told you in the previous video, we need to first find out actually this key is present in which node, whether it's leaf or internal. So 84 is greater than 61 here. 84 is less than 87. Okay, here now. But now 84, when we perform the deletion operation in this node, we have only single key, right? Okay, fine. So now to perform the deletion operation, let's say we have deleted this, then we are left with blank over here, right? It is violating the minimum key rule. So what it will do, it will ask from either left or right sibling, but there is no left sibling, there we have right sibling. Now right sibling will not be able to give the key, then it will ask for the what your the parent node, right? So the parent key has to come down and merge with this one, right? Same process will be followed. So what we are left with then, this side will remain as it is, this one as it is. Let's see this side. So when it will be merged together, this 87 has to come down and merge with both of them. This one is empty, this one is 95. So when it will merge, we have 87 and 95 as it is. But when it will come down, its place will be empty now, right? So again now, when this place is empty, it will ask for the values from either left or say the right sibling. There is no right sibling, we have the left sibling. But again, left sibling have only one key. So it will again say, no, I won't be able to give you a key. Then this node will go to the your parent key. So parent key has to do something now, and what it will do, same, it will just go down and will merge both of them, right? This is what the only option that parent will have. And then let's see what it will looks like. So when it will merge both of them, let me just write 39, 45, 48, and these as it is 30 and 28. So when it will ask for some help from this 41, it will say no. Then 61 has to come down and merge with both of them. We are left with 33 only, right? 33, this part will remain as it is so far. And now for this side, right? Now for this side, 41, this will be merged together. That is what we have, 41 and then 61 as it is, right? So now see, now complete the structure. When this will be merged together, this 41, let's see this 39, we need to arrange these now, right? So 39 is on the left of 41. So the left of 41, we have 39. Now this part, 41, this one, the right of the 41, right of the 41 and the left of 61, right of 41, left of 61. So this branch will come over here, or say the subtree, and this part will remain here. So in this way, our structure, our B tree structure will looks like. So this will be, we are having when we perform the deletion operation of 84. The next is insert 50, right? So out of this one, now we have to insert 50 in this one, right? So when we perform the insertion of 50, again 50 is greater than 33, will come over here, insert the 50. 50 is greater than 41, less than 61. So 50 will come over here. So what will be what we will have, 45, 48, and 50. We have this value in place of these two. Again, this is an overflow condition, right? So let me just tell you one thing. This is very important actually. If you might have seen my complete this database series, and when we just started this database indexing part, file organization and indexing, I told you there are two things that we generally need to understand when we just try to write the algorithm or say the code for this insertion, or whether it's a deletion operation in Python or C, any language. When you just try to write, you need to take care of two things. One is your overflow condition in a node. When this occur, where either we perform insertion operation or deletion operation, overflow condition. Again, other situation is underflow condition. You need to check whether underflow condition will arise in insertion or deletion, right? So these scenarios we need to understand very carefully, because on the basis of this, I told you in the very beginning, when the complete database is already designed, right, there were two approaches. So these approaches I have already explained over there. One approach was when we just try to put a key in a node, and if there is an overflow condition, we have two situations. One situation is we will change the structure of our B tree, for example, indexing, right? And the other situation is we will split the node, right? If we change the structure, means our order will, if previously the order was 3, now the order is 5. So now we will be able to insert the key in the node. This is one approach. Other approach is, instead of changing the complete structure of a B tree, we will perform the split operation, right? And in that case, we need to check overflow and underflow, right? So this scenario is very important to understand when we generally used to go to the designing part of our multi-level indexing. That is what your B and B plus tree, right? So that is already completely mentioned and completely explained there with the help of example and a very important points in the previous video. Make sure you go back and watch if you have not. So coming back to the same, we have 45, 48, and 50. Again, overflow condition, because the order is 3. So we'll split and we'll take the middle value, that is 48 in the above. So we'll have look like 33. On the left, we have 29, 28, and 30. And in this side, we have 41, 48 from the leaf node, and then we have 61, right? So we'll arrange 39, we have 45, we have 50, and we have 87, 95. But again, recursively, we need to check for every node. It should not be an overflow condition. But again, we'll see in this node, there is an overflow condition. We have 3 keys over here. It should be 2. Again, split this node means 48 will go above. So our structure will look like 33 and 48. Make sure you write these values as it is. And then for this one, see, 40 will go, 48 will go above. So we have 41 left over here. Yeah. So 41. Now the key, the branches of 41, say the subtree will remain as it is, 39 and 45. And in this side, we have 61 and the rest of the subtrees as it is. That's it. So this is the final B tree structure that we have after performing the insertion operation, right? So let me know if you face any difficulty in understanding any of the point from the previous lectures when we started performing the insertion operations over here, and along with the deletion operation. Make sure. So we have understood that insertion is quite easy, but to perform the deletion operation, we need to take care of a lot of small points. Right? We need to perform the rearrange. So if you have already a few knowledge of your data structure where we used to understand AVL tree, red and black tree, so all those things, and also we have M-way search tree, 3-way search tree, 5-way search tree. So similar kind of operations are generally being followed over there also, including the rotation. So that's it for B tree deletion. So make sure if you have any issue, let me know. And just wait for the next video. I'm going to uploading the video for deletion operation in B plus tree as well. So there is a very similarity in between B and B plus tree deletion. But again, we know why we use B and B plus tree. What's the difference? Which one is the best for linear search? Which one is best for sequential search basically? And which one is for, searching in between a range. Right, so we have understood all those things. What's the basic difference between B and B plus tree in the previous lectures? If you haven't go through them, make sure you go back and watch the video. So okay, that is for today. We'll see you in the next one.